All right, this is chapter 1.4, example 1. The question says, does the set of data below show an exponential function? Justify your answer. Well, again, we got to find the differences. So this is plus 1, this is plus 1, this is plus 1. It is always good to check that because that way you know we're consistent on this side. Don't take it for granted. And then over on this side, if you wanted to check it was linear, remember you realize that this is plus 4, this is plus 20, this is plus 100, this is plus 500. So you know that obviously that's not linear. Erase that real quick. All right, so let's try the ratios. So the ratios, 5 divided by 1 is 5. So this one's multiplied by 5. 25 divided by 5 is also 5. So this one is multiplied by 5. 125 divided by 25 is 5, so this one's multiplied by 5. And then last but not least, 625 divided by 125 is also times 5. So we have the same ratio over here. Basically what I mean by ratio is the same fractions. They're all being multiplied by the same thing. Then it is exponential. This is, yes. If I use a pencil. Yes, it's exponential. And I know the instructions don't say it, but I want you to go ahead and write the equation. Remember, A is your start, B is your ratio. So we're over here. A equals start. B equals ratio. So in this case, your starting point is 1. So A is 1. And your ratio is 5. So B is 5. So Y, let's get that towards a little clearer. Y equals 1 times 5 to the x. And we don't have to write the 1 because 1 times 5 to the x, well, 1 times doesn't do anything, so I'm just not going to write it. 5 to the x. And that would be your equation. Okay? Go down and try it, number 1. See what you can do. I know it says don't write the equation, but attempt to write the equation. See how you do. Okay, hopefully by now you've tried it. Let's do it real quick. If you haven't, pause and give it a shot. We're going to do the same thing. So on the left side, we're all adding by 1. Good. You student, you check that out. And hopefully you realize it's not adding the same thing because our decimals are changing. All right, we're getting bigger and bigger. So we're going to try working it out. 1.44 divided by 1.2 equals 1.2. So we're going to do times 1.2. Then we got 1.728 divided by 1.44. 1.728 divided by 1.4. We get also 1.2. 0.2. Then we get 2.0736. 2.0736 divided by 1.728. 2.0736. And that would be the bell, 1.728. It is now 8 o'clock on Friday. It's also 1.2, so this one's also 1.2. So, these are your ratios. They're all the same. So, here we go. Your A value is, remember your A is your start. A equals the start. And in this case, the start is 1.2. B value equals the ratio. So in this case, it's also 1.2. So we're going to write it like this. Y equals 1.2 times 1.2 to the x. Now this is an actual special case. All right, this is a bit of a special case. You notice how the 1.2 is the same? All right. Well, in this case, if you ever have the same base, so like example, if I'm ever doing x squared times x to the third, the way you combine those is by adding the exponents. So 2 plus 3 is 5, so it's x to the fifth. You got to have the same base though. Well, in this case, I got the same base, and remember there's a little 1 right here. So we can write this as y equals 1.2, and this is 1 plus x, right, to the x plus 1. Now, if that confused the absolute mess out of you, don't worry about it. I'm not going to sweat it. But That is something to make this a little more mathematically savvy. If you showed this to a professor, they might yell at you for this right there. But it is what it is. I will happily accept this as your answer. All right? Thank you. Let's look at number 2.